I guess I should open up a blank project then.
Yeah, just totally blank new project. And we'll just kind of start from sort of the smallest elements and kind of just build our way up to doing some stuff with them. And we call it practice project or code practice or
Exercises.
nothing fancy. Doesn't really matter. Position's fine. Let's just keep it 3D. We're not really going to be doing a whole lot of graphic stuff at first, anywho. And yeah, I know I've explained. Basically, Unity's simpler in 3D anyway. The 2D.
Yeah, I think so. Yeah, the
stuff.
2D is like an afterthought. So of course.
Yeah, it's kind of forcing it into 2D, but a lot of 3D stuff still applies. So it helps to even know the 3D stuff first before diving into that stuff. Let's just create a new game object, a cube. Drop a cube in there. From the game object menu.
Where's the 3D object and cube?
Yep.
Okay, and then we
There you
can
go.
double click or. Oh, I'm in the game view. That's why it won't zoom on it. Okay.
There you go. And let's start off by just adding a script to it. A new empty script. Which I can go to new script. And let's just call this one practice, because likewise the purpose of this one's going to change a bunch too. So we're just going to first do some console log outputs. And then
scripts do nothing unless they're attached to an actual object.
That's right. So if you'll open up the practice script, we'll look at it in mono develop. That's where we're going to be for the first bit of this stuff.
I did go through. I haven't actually done a lot of work since the convention, because a lot of times that's what I do. I end up doing a lot of work, and then all of a sudden, like once I'm done and I finally get to the convention, I get to after the convention, I'm just like, I still don't really wanna, because I work.
Sure. Yeah.
So like I did go to the boards and I cleaned up the boards a little bit, but other than that, I haven't really done anything.
I mean, that's good to do while it's still in your mind.
Yeah.
For sure. So the first things we're going to do, we're going to be purely in the start function. We're just going to kind of write some code that's just going to happen once. It's going to be simpler to keep straight what's going on before we do anything in the update function. But first off, just throw a debug log in your start function, and we'll just say, you know, code reached or code run or something, just so we can see that the code is happening.
Run, or I guess we'll call it start. Sure. Start has run. And as much as possible, don't tell me how to do things.
Sure.
Let me struggle for a minute.
Okay. For sure. Okay, and if you just press play, we just want to make sure that comes out to the console log, because, you know, until it does this much, nothing else is going to be visible for us to see anyway.
Oh, yeah, I need to change my settings. Yeah, change my settings there. Maximize on play is off.
And now why is it hidden?
And because it's there. Okay, there we go.
Sweet. Okay, so far so good.
Starters run. Baby steps.
Yeah, that's right. And if you want to, just for, let's say, have a public variable on it that's an integer. Do you remember how to do that bit?
Yeah, we want to put that over here. Public int. What kind of integer is this going to be?
We'll just say some num. Once again, these are all going to be kind of generic. We don't have there's no real purpose in this case besides like a number to set.
Okay.
Okay, and so let's set that value in the inspector to 5.
Equals 5.
Or so let's set it in the inspector. So let's make it in the inspector now 15. So you've set it in code to 5, but let's go to the inspector.
Oh, okay, yeah, I see what you're saying. In the inspector, it should be over here, so it needs to pop up. It needs to update. It did. So we'll set it to 15 over here. Okay. And then there's nothing to tell us in the debug, so we need to create a debug for it, right?
Well, so speaking of which, let's actually just print it at the end of that line. So it'll say start has run, and then at the end of it, it's going to say, like, on the very same line, what that number is. Okay, so it'll say on the same line, so it can't be a new debug statement. It's going to have to say start has run, the value is, and then it's going to print out the word, or print out the number.
Okay. The value of some.
Well, as a reminder too, I'm sure you remember, but because last week we took off, we have 2 whole hours this weekend.
Right. Yeah, I do know that.
Okay.
I mean, so that way we can do some stuff with 6 a little bit,
sure.
but we can do some practice stuff.
Don't want to surprise you, in 40 minutes. Like, by the way.
No, I am completely ready. The wife is ready. We're all ready. And then some number, or plus some number. That should be good. We did the space, so it'll be spaced out.
And what do you expect to see when you press play?
15, because that's what I set it to in the inspector. Some number is 15, yes.
Nice, okay.
So if I set it to like 200, it'll change to 200. There.
Now, do you remember how, so in the code you've set it to 5, right? At the
Right.
top, you declare it. Do you remember how, what you can do in the inspector to get it to grab that 5 again? So not setting it back to 5, but there's something you can do in the inspector that'll be like, refresh the value, because, you know, let's say, in fact, let's say, while you're in the code, basically, if we had changed that number to something else in the code, how do we get it back to show up over here without typing it in?
Is it a gear thing? No. Reset? No.
Try it.
Try the reset? Oh, the reset. Wow, okay.
Yeah. And that fetches whatever the numbers are in the code. So even if you would change that 5 over here to like 35, reset would be a way to say, forget whatever's in the inspector, grab stuff from your code.
Okay.
Okay, so let's put an if-else statement after your debug log.
Okay.
And if some number is positive, then say one thing. Otherwise, say something else.
Okay.
And it'll all still be in start.
If number is positive, so if it was basically greater than 0, be one way to do it.
Yeah.
Then we'll print out something like positive, or I guess I could say some number. Actually, I want to do it properly. Camel case is positive. And okay. And then that's going to be there. And then we do an else. I mean, we could do an else here, or we could do an else if, either one.
True.
Because if it's not positive, it's going to be negative, so that's a Boolean already.
So
you know,
maybe
it's a logic type of thing.
So now that you mention it, let's actually change this a little bit. So it'll print out some number is positive, or some number is negative, or some number is neither. Because there is a case where it's neither.
Yeah, with 0. Okay. Yeah.
So then, in that case, you're going to have to do something a little additional.
Okay. Space if for an else if in Unity speak. It's not the same word as it is in. I think in C it's the same word. I want to say
they're still separated there, and so actually part of what's going on is sort of this weird, tricky thing going on where it's technically else is a keyword, and then if you don't give it braces, it assumes the thing after it, and so else if is actually sort of emergently created from else's behavior and a standalone if statement.
Right.
But as it works out.
Is less than 0. Then do this, else, and then of course we can do the debug log and paste it in there. The two difference is positive, is negative, is neither positive or negative. Clean this up here. Just for programming, make sure all of our stuff lines up for what do you call that, just to make it look good.
Indentation.
So right now if it's 5 it should say it's positive. It's positive.
Sweet. And if you yeah, just go and do a few tests.
-5 it should say it's negative. It's negative. And if I make it 0, then that should be neither. It's neither positive. So that else if definitely working.
Sweet. Now, so I'm not sure if you have any questions about this, let me know. But can you pull that into a separate function? Because what we'd like to do is that whole if-else chain. We'd like to put in its own function where we can call it and give it some number and be like, you know, positive check parentheses some number.
So void some number, designator, I guess, something like that.
Maybe just pause check or something as the name of a function.
Yeah, pause check, something like that. It's void, so we don't have to put anything in there. It's expecting. And then we're going to just drop this whole thing in there, basically. Control X, Control V, and then we can just call some number, pause check here, and just like that, and that should work. Yeah, that should work. So it should do virtually the same thing, but in code. Now we can call it in multiple places.
Yep.
So it's saying that it's neither positive or negative. I change this to 5. Should say that it's now positive. Yeah, so it's working.
Sweet.
Is there anything cleaner I could have done there?
So let's make, instead of it, so right now it's using some number as like the global value. Let's make it so you pass that a value. So for example, let's say we have another number on here. There's public int some number, but there's also going to be another integer called like other number at the top.
So a public or a private?
Yep, let's also be public. Other num.
Or new number.
That can default to whatever you like.
Let's say 20. And so now...
Yeah, because now we'd like to be able to call the same function on both of those values. We'd like to be able to say some number check, some number check, pause check, new number.
So now we need create another local value here.
An argument or a parameter.
Right. So that would be number argument. Of course, I need to set that somewhere. Don't I need to create that variable?
So it's gonna, so that's sort of like, so where it creates it locally.
It just creates it locally for me.
So within that context, and so there's sort of a few pieces to this puzzle. For one thing, let's rename your function from some number pause check to just pause check, and I think that's going to make it a little easier for us to keep straight that that one's in no way going to be tied specifically to some number anymore.
Okay.
And so you'll change it there too. Because now where it says pause check inside this parentheses, on where your cursor currently is.
Yeah.
So that one needs to know its type. That one needs to know if it's an integer, if it's a float, if it's a whatever. And then you can give it a name.
Pause check. We're saying this is the what type of variable is it? It's called
This is an argument or a parameter.
Argument. Okay. So this for argument.
And so now instead of your comparisons being against this the word some number,
it's going to be a number argument. Okay, so now in order to pass it in, we come up here to pause check, and we can do this one versus some number.
Yeah, let's go and call it on both of them.
And then we could do another pause check on new number. Save the function. Should see a new thing pop up. There's our 20. So if I wanted to, I can make this -5. And now one of them will say higher than, the other one will say lower than. Yeah, is positive, is negative.
Although, so notice, of course, it's still saying some number is as part of the string. Let's make it so as part of calling that function, you can also give it a string.
The name.
So you'll have a new argument, which is going to be a string.
So this will be.
Well, so this doesn't need to be a public.
It can be declared. Okay, so we can go int number argument and then comma, right?
Mm-hmm.
It'll be a string.
Mm-hmm.
say number name arg.
Or var name or something like that, maybe.
Var name.
And so now instead of some number, you want to print out whatever that is.
Right. So that's going to go var name plus, and then we need to delete all this. Make sure there's a space there, and then do that same thing. Right here. Save, and of course we need to feed it in up here, otherwise it won't. So the name, so I could just use this, some number would be the, that would just declare itself as a string even though it's not, you know what I'm saying? Like even though it's not really looking at the variable in this case, it's just adding in this as if it as a string. You know what I'm saying?
Yeah, although what it's going to do is it's going to interpret like 5 as the string.
That's right. That's right. I have to do like quotes around it to make
There's actually no, at least no generic sort of approved way for code to be able to like print out the word of a variable itself. Those are all kind of hidden from the player side.
Right. So
and of course the second one, instead of calling it some
new number. But if I wanted to, I could also associate, I could put these in a, what do you call that, a construct of some sort. Oh, I did talk to some programmers while I was there on one of the nights, and they talked to me about, what is it called? There's a book, and I tweeted it out that I need to read, where it has like the same problems that programmers face all the time type of thing.
Design patterns?
Design patterns, yeah.
Yeah.
The 8 design patterns, or whatever it is. Or the gang of, what do they call it, the gang of 4?
There's a bunch of things that fall in these categories. There's actually a great version of this stuff called Game Programming Patterns, which is completely free online. That may be of interest, and I can point you towards that.
So it looks like it's working as intended. Yeah. Some number, new number. Of course, this is off our start, so I'm not too worried about that one right now.
Right on. Okay, so now let's create a public array of integers on your practice script.
Okay. So
let's make this one separate, just, you know.
Yeah, public int, and then it's going to be an array, is going to be bracket.
Yep. Well, here's a link to the free online copy of the game programming patterns if you're curious to browse through it later.
Yeah, I'll go ahead and save that off. So I'll just leave it up and I'll save it later. Yeah. Okay, I probably need to turn off Steam. There we go. Steam, for some reason, occupies a lot of internet.
Oh, sure. Well, I think it's always constantly updating stuff, and it's also constantly downloading things like new, what is it?
New ads.
To show in the store.
To, show you. Be like, here you go.
When Steam was new, I just remember feeling really repulsed by the idea that this one company, for this one game, wanted to run this thing in the background of my system 100% of the time. And I'm still kind of mildly annoyed by it, but clearly it has taken over mainstream approval of it just runs on everyone's machine all the time. It's just accepted now.
I mean, it comes up automatically, and I shut it off every time unless I have to play a Steam game. It's one of those things where if you actually have to stream, if you are trying to stream a game while that game is accessing the internet and Steam is going, good luck. It's not going to work for you. Like, you can stream a game as long as and have Steam up as long as that game isn't also accessing the internet actively, you know.
Right.
So, yeah, it's just one of those things.
So let's just name this num list or something like that.
Okay, so that's going to go after, I believe, num list colon, and that's going to be, and then it's going to size itself depending on how many variables we put in it, right?
Well, so if you look at it in the inspector.
Oh, that's right. The inspector is where we can assign tons of variables
since it's public. And it may or may not be unhappy with the spacing. Oh, it's fine. So because it lets you get away with it, I do want to point out that if you look at where your code is, by convention, the space would be after the brackets, not before it. So we would say like int brackets space num list. It turns out the compiler's fine either way. But like, yeah,
Okay, so there needs to be a space in between these two?
Yeah, I would, basically we'd always put a space there. The compiler doesn't care, but just as a note of convention.
As a convention, yeah.
Similarly, we would often actually leave out the space between the int and the brackets, because it kind of concisely says that this is an integer array, as sort of think of it as a single concept.
Okay.
And it's kind of like with indentations, where the compiler can tell them apart, so it doesn't mind. But
well, for me, I think that's really important. Small things like that are important to know because, like, eventually, when I'm going to apply for jobs, they're going to say, "Let me look at some of your code."
Yeah,
and if it looks like garbage, even if it does work, if I code in such a way where their technicians are going to have a hard time reading it,
sure,
then little things like that make a difference. I think.
Yeah, totally agree. And so if you look over the inspector now, you should have a way to let's like put 4 numbers in there.
Okay, so we say 4 to give it a size, and then we can put some numbers in here. So we could say like 23.
Let's say some positive, some negative,
47,
some 0. We're going to use that function we've already got.
Negative 42 and negative 1,000.
May as well leave a 0 in there somewhere, just because
it's one of the things
sure. we can test for.
And a 0.
All right.
Okay.
So now, can we print out from our and let's go ahead and comment out in our start function these previous pause checks.
Okay.
And let's also comment out the debug log as well. We're just gonna.
Yeah, we don't need that anymore.
Yeah. So at the end of it, can you debug log out the size of num list? How many numbers are in that list? So we expect us to see print out 4.
So it'll be num list, and then it's just calling size on it, so it should just be size like that, I believe.
So num list isn't a function, so we can't use that form. But if you put a period after num list, it should give you some options.
Size.
There's some other word for it.
Get size. No. Get length. Get length sounds no. That's probably not it either.
I mean, so if you click on it, it should actually give you a little tooltip, which may be able to.
The number of elements. Okay, so it is get length, right?
Yes. So you can actually get length, or you can actually use length directly. You'll notice that there's also an autocomplete for if you get rid of the G. Length will also just be number
of elements in the array, whereas the other one said.
The difference is if you had a multi-dimensional array, so a 2-dimensional array, you could this way ask like how many wide is it or how many tall is it. Length will always just kind of be like how many elements do you have total. And so if we have a single linear array, they give you the same value.
Okay.
But it's much more common to use just .length in the case of a linear array, since it's the same as asking how many are on axis 0.
So we're just going to do length.
And let's double check that prints out what we expect.
Leave my room, please, now. I don't want shit in my bedroom.
And is it printing out what we expect?
Yeah, it looks like it is.
Okay. And so, if we go back into the code, let's create a local variable right inside that start function. So right before your debug log, or let's say actually after it.
This video, I'll probably make this part of the video public, so you can actually link to it from your website type of thing, because this is great stuff to go through, I think.
Yeah. And so after your debug log, then let's create a local integer.
So it's just a public, or we want just an int.
Yep. And so then, the idea here is we're going to start off by having a counter, and so you can just call this counter. It's going to start at 0. We're going to be increasing it. We're going to kind of like write what if for loop could do. We're going to do it with a while loop. That's my phone reminding me I have a call with you in 20 minutes.
Oh, it's good.
Which of course is the same call. So counter. It just equals 0 for start.
0. Are we going to do this in the update function?
We're also going to do all this still right here in the start.
Okay.
And so as we have to, since that integer is inside start, it's not accessible outside.
Right, you're right. Yeah, okay.
And so let's do a while statement.
That one.
And you want to check and see while counter is less than however many elements you have in your array.
Let's see, that would be num list dot length. then print out debug log. Dot log.
And for now, just print out each one of the numbers from numList. So
Right, so
numList.
Dot.
So actually, there's going to be another line that's going to help us do this. So for temporarily, let's go to the next line. We'll come back to this line in a sec. Just close up its parentheses for now, and you can come back to it. So on this next line, we want to increase counter by 1. Because remember, if we don't do that, we'll never get out of this while loop.
Right, so counter.
Yep.
Plus plus.
Sure. And we're just going to basically do, this whole thing can be done with a for loop. We just want to do it first as a while for kind of review of how they're different.
Right, because while will go like one more a lot of times, right?
Just
like with this one.
Totally depends on just how you write it and where the stuff goes. But we'll see them compared in a second. So instead of debug logging numlist.clone, that clone is sort of left over from when you were moving past this. So you want to print out the value at counter. Remember, you're going to use bracket notation for this.
Okay, so dot and then brackets.
No dots. Never any dots for array access.
So
just the brackets.
Just brackets. Counter. No, is that right?
Yeah, that should do it. And then you got to close up your debug log. And so if that worked, then first of all, can you walk me through verbally what this whole thing should be doing? Sort of the new bit, starting from int counter equals 0.
Okay, so we set the counter to 0, so that's what it's going to start as. If it's less than, which it is, less than numlist, which is 4 right now, dot length, then we're going to do a debug log numlist. So, and then the counter is set to 0. I'm just trying to figure out why we couldn't just say counter here. Can we just say counter?
Well, so we don't want to print 0, 1, 2, 3. We want to print -27, 0, 1000, whatever the numbers are in your list.
Okay, so what we're saying is the counter is saying the element of numlist at what we're saying. So because the counter is 0, the first element, then numlist will return the one that's the first one on the list instead of just giving us 0, 1, 2, 3. Okay.
Now speaking of which, actually, let's make that more explicit here. Go ahead and make this debug log have at least more than one other part, where it's going to say like the element at counter is numlist at counter.
Okay. So the element. I still remember when I didn't even know how to do this.
Yeah.
At space colon, or I guess those are whatever. At counter is, yeah, that's right. So we're saying at counter plus counter and then colon space is space colon and a plus. Okay, and then numlist, right, and that should do that.
Sort of. You're still missing one other thing in that line.
The element at basically 0 for the first one is, and then it tells me that. Am I missing a colon or something?
If you look between counter and is.
Oh, there's another plus that I need. Okay, there we go. There we go, and then everything is happy. Right. So if I do that, then I should see a bunch of stuff in my console log. So 0 is 23, 1 is 0, 2 is -42, and 3 is -1000, which is true.
Sweet. Okay, well, and so now let's call your pause check function on each one of those values.
Okay. So we can still do that within the while loop, so I can just do pause check, and then I need to feed it 2 values. One of them's going to be the num list colon counter, not colon but brackets counter. Comma, and then an actual name. So we could, in order to get the name, what are we gonna do?
So you can create a name here with a string. So just like you were able to print out, the element at.
So I could
sort of
just
construct one with a string.
right. So we could just yeah, the element, or I guess we could just say element.
Yeah.
Space. And then do a plus, right?
Yep.
And then the actual counter number.
Mm-hmm.
And that, and the colon, and that will run that void function. Or, well, I guess it's not a void function. Oh, it is. It's not a void function because we're feeding stuff into it. We're feeding arguments into it.
It's a void function because a void has to do with the return value, not the input.
Oh, okay.
So it's because it doesn't have any output, it's void.
Oh, okay. So then, yeah. Because it will create, okay. So file, save. It seems like when we're doing object-oriented programming, most of the time we're using void functions. We aren't really using regular functions typically.
I mean, so void still counts as regular. The difference, you are right that oftentimes we're using functions that kind of contain and label code. Object-oriented can have plenty of return values as well, especially, so something we haven't worked as much on is if you want to do work with encapsulation or containment, there's a lot of things like where you saw like you could use .length or .getLength. Those have to do with whether or not the value length is directly exposed, as opposed to getLength is sort of an accessor, where only to get for that role to get it, it has to ask permission and go through its sort of approved means. In those cases, it's always a return value, but we've sort of just instead because you're the only person working on your own code, we've also often kind of given you direct access to the variables for simplicity's sake. But
okay.
But yeah, so if we want to test this out, it looks like it should be.
Should be good. Yeah, it looks like it's saved already. I already saved it. So it should now tell me. I end up clicking on that play like twice all the time. The element 0 is 23. It's positive. 2 is negative, 4, 2 is negative.
Checks out.
3 is negative, yeah. Okay.
Okay. So now, so can you rewrite that with a for loop as a bit of practice?
Okay.
And so basically, you know, we might even put a debug log in the middle that's like a spacer with just some dashes in it or something. And then we're going to run a for loop that should print out the exact same contents.
For loop functionality. I think people would like hate to like read my code because I end up using these really long, large words. That's one of my problems with writing what they call enlisted performance reports too. For
in some cases, it's better to use a long word than to try to use some sort of abbreviation that only you would recognize. Because that's a problem. I see many more programmers make where they'll try to shorten everything to 3 or 4 letters long. You can't,
oh, and then you don't remember. Yeah.
You can't keep straight which way they're trying to abbreviate counter with CTR and whatever.
I believe it's comma I plus at the end.
Although those shouldn't be commas though. Those should be
colons. Or I mean semicolons.
Yeah. You were semi-correct.
And then this is going to be if I is less than we said 4, or I guess we could give it a variable. We could give it the length, the numList dot length, because in this case that could be variable. We can that'll allow us to what do you call it, dynamically adjust the size still, and this is still work. And then basically the guts will be the same, well, except for counter minus counter plus because that's built into the for loop, which is nice.
Yep. Yeah, and the thing to keep in mind is that all the for loop is doing is really exactly the same as what you wrote with the while loop. It's just that you're specifying there is like that first part before the semicolon happens before your for statement. The middle part's happening where your while loop's argument is, and the last part happens at the very last step of your loop. Does that make sense?
Yeah. Okay. So I should probably put a space here. Yeah. And this should not be spaced there.
There you go.
And just to make sure everything's clean. It looks pretty good.
And if you check the log, we should see the same contents of it come out.
Yeah, except in between it'll say for loop functionality.
Right on.
Index out of range.
Oh, interesting. Let's look at where that's coming from. If you double click on it, 29. Element at list.
Oh, it's because of the way we've.
Yeah, counter is no longer what those should be using as their number. What should they use instead?
It should be using int I, so it'd be I.
All that affects a few places.
And then that should also be, counter should be I here. And I should be right there.
And one other place?
I should probably unpause that. Counter, counter, counter. There we go, one more. Now this is like a de facto standard inside a for loop using I.
It's just sort of in lieu of some better reasons to number it. And so I mean, there are people who will go on a inquisition saying that, you know, the word should always be a label of what it is. So this might be like int, you know, in this case, which number or something. They would prefer a bigger number or a bigger more descriptive
variable
label.
Yeah, instead of I.
Which there's something to be said for. That said, if it is specifically just an index into an array that's linear and you're looping through each element of it, many programmers will just stick an I in there.
Right. And then if you were to, whatever it is, seed another for loop within a for loop, you would use what letters default?
So I is just sort of think of it like
like Roman numerals.
Yeah, yeah.
Almost.
But again, pretty quickly those things can get a little sketchy, and so a lot of people will prefer to, if they're going to nest it,
make it explicit.
It might be good to label them like row and column or X and Y or something else more obvious about why. You know, Y is one of these I and Y is one II. Is often helpful.
Yeah. Okay, so this time we should have been fixed, and where's my debug log where it says I'm going, yeah, for loop functionality, so 0 is 23, and then 0 is 23, it's positive, and then it's going through all the rest of them the same.
Check out.
Yeah. Okay.
Nice. Okay, so let's create a new, let's temporarily disable our cube. Let's give our cube a break. So let's turn off in the scene. Now let's create a new game object. We're gonna start doing some stuff with multiple game objects and things. Let's just create a cube, a sphere, and a let's actually create 2 cubes and a sphere.
Okay, sorry. 3 object, another cube. And sphere.
Let's take one of those cubes and put it down below the other stuff. That's it.
Okay, so you want to put the sphere on top?
Yep.
So it's like a snowman.
Okay, yeah. Although let's take that bottom cube and then stretch it out long ways and basically make a flat ground out of it. The bottommost cube.
The bottommost. Okay. So we'll just scale the X and the Y. Oh, I did negative. I don't want to do negative. Let's just make this like 20. And the Y will make 20. Or no, not Y. It'll be Z. Right?
Yep.
Yeah.
But you can always remember to look at the widgets in your UI editor.
Yeah, I was just looking at that. Yeah.
Yeah. Okay. So you've got those. Now rename that one to ground, so it has a more descriptive name than cube 2. For your other cube, instead of cube 1, let's call that player. And then for the sphere, let's just call it ball, which name might change, but it's something more descriptive, I suppose, at least.
Okay.
And now also, if you press play right now, what do we see currently, or like what perspective do we have on the scene?
Free aspect.
Okay. Well, so that's just that's our proportions for the view. But I'm just wondering where the camera was.
Local.
Let's get the camera to look at it from a more pleasant angle. Do you remember how to reposition your camera?
I believe if I come over here, there's a thing for this.
Well, first of all, get your scene view where you'd want your camera to be looking from. And so for that, maybe focal point on the cube.
So maybe like that.
So remember, if you click on your cube and press F, you can focal point on it.
Right, so like that.
Yep. So that seems like as good a positioning for your camera.
Nice little 3/4 view.
Yeah. So now you'll need to select your main camera in the hierarchy. And now you're fishing around in those menus, but it's going to be under the game object menu, and it's one of those options which is going to, what it does is it tells your camera to go where your scene view is.
Move to view, align with view. Align with view, I believe. Yeah.
Bingo.
Sweet.
Yeah. Okay, let's put a script on the player.
Okay.
It's a new script. Let's call this a player move, or control or something.
I have to make it all one. Okay, create an ad. And then okay, and now we need to are we going to do the clicking player move, or are we going to do the WASD player move?
We're gonna use some arrow keys inside update.
Okay.
And so first off, let's just get it so inside update. Let's just make it first check if you press like the K key or the M key or some sort of key. How do we check and see if you input a certain key, debug log something?
Okay. So input
So you gotta have an if statement.
dot. Okay, that's right. If input dot get key down dot, and I guess we'll do W.
It's no dot. It's gonna be parentheses. It's get key down's a function.
W like that.
Nope. So if you'll go back to when you open up the parentheses, it says what types it wants, and you'll see it wants a key code of some kind.
Key code.
And so it's gonna be key code dot something.
Dot W.
Yeah.
Okay. Then
in this
I
case,
wanna
just debug log key pressed or something. We're not gonna worry about the motion just yet.
key pressed.
And let's test and see if that does what we expect. Oh, seems unhappy. I think there might be
It's a stray bracket or something.
I think in particular there's a parenthesis that wants to divide up your.
Down here, so
Nope. If you look at your if statement.
what did I do?
Your if statement's opening a parenthesis. Your get key down's opening a parenthesis.
Oh, it's there. Yeah, you're missing a parenthesis. Okay.
Yeah.
There we go. The world is safe again.
Yeah.
I think makes sense.
W key pressed.
Yeah. Press
Twice.
it all day. Twice on
Right.
Sunday.
Okay, well, so now how do you get, so if you press the key, your object can move forward? Do you recall, or is this going to be a...
So it'll be like, yeah, this is going back to the what's it called, tutorial, the ball, the ball demo, bouncing ball demo. So this would be, we just need to figure out what axis we want to move on. So I guess we'll move on the x-axis. So we'll say x++.
For now, any motion will do, and we'll kind of move towards whatever we need to.
So it'll be, so I need to get the component, the game object, so it'll be game object dot transform.
In this case, it would be a lowercase g for the game object because it's the game object that the script is on.
Right. Okay.
But as it works out, we don't actually have to, you can actually get the transform directly in your code, in the same way you can get a game object without specifying who. If you say transform dot, it's always the transform of the thing the script is on.
Okay. So the P transform?
I'm not sure.
Or there's two of them. There's a P and a C. Oh, there's the cap lowercase.
The lowercase. Yeah. Now it's just being public as opposed to class.
Dot
positions, which you're after in this case, to change position, right?
Position dot x.
So you can't actually directly modify the x, y, and z's of the position. they have to be modified as a whole, as a vector. So you can take transform position plus equals something, but you can't directly modify like the x, y, or z of it.
Okay. So
just
plus
knock off the period x.
Okay. Plus equals.
Yep.
And then transfer. Or do I just do one, or?
I mean, no. So you have to specify which directionality. This is why you have to use a vector, and so it could be a relative one if you want to use transform dot. Do you know some values you can put after this?
Is it position again?
Nope. No. We might use forward, right, or up. Those are relative unit vectors to us.
Okay. So we'll just say forward. Sure. Why not?
And so.
Do we need any? We don't. That's not a. That's not a function, right?
That's right. Yeah, not a function. It's just a normalized three-dimensional vector.
All right. Yeah. So now it's moving rather jaggedly, but it's moving.
Okay, so let's get it moving less jaggedly. How would you go about doing that?
We need to basically give it a it's like a timing thing. It's like a there's a way of smoothing this out.
There's sort of a couple bits. One of them is right now you're checking get key down, which only responds the very frame your W key is pressed.
Right.
But there's actually a different function we want to use. One is input dot something else, which will fire any moment the key is held down, as opposed to just the moment the key went down. So if you'll press get key down.
If I'll erase it, okay.
Yep. And there's going to be a different input dot.
Let's see
what our options are.
See what our options. Put dot. It's not dot. Okay, there we go. Oh, acceleration. I don't want that.
Nope.
Dot. Compass. Let's see. Equals device orientation. Get axis. Get button down. That sounds.
So if you look at the get keys family, there's actually 3 variations of it, and these same patterns actually apply to a number of them. They apply to buttons. They apply to mouse. They apply to keys. But there's a get key down, and a get key up. Do you remember the difference between these 3?
Get key up is going to measure when it's actually not depressed. Get key down will.
What do you mean by that?
Like when you aren't pushing it, right?
It's the single instant that the key is released. So like if it's continuously not pressed, it won't fire constantly. It'll fire only the moment you press and release the key.
So it was down at one point in time, and then okay. And then get key is just going to get the status of the key, isn't it? So
yes,
it'll just return the status, either it's down or up.
So I mean, it's returning a true or false. In which case do you think it's returning a true?
Right, and then down is just telling us if it's down or not. So that's the instance you put it down, basically, and as you're holding it.
Yeah, so down is the instant you're putting it down. Up is the instant you release it. Get key is the one that tells us if it's currently held.
Oh, if it's currently held. Okay, so we want that.
And admittedly, these names are a little confusing in that down certainly sounds.
So we don't have to say like .true or anything.
Nope. No.
Just get key.
We'll never be saying .true. In this case, so like what you might be thinking of is that we could put at the end of our if statement, between those clothing parentheses, you could say equals true. But we would never. So as soon as like after the key code .w, just to see where it would go, after the parenthesis, between the parentheses really, you could say equals true.
You could say
it's going to have to be outside those parentheses. It's not applying to W. Yeah, between those two, equals true. So that is what this statement is explicitly asking, but an if statement is already
implicitly asking that.
Yeah, that's what an if statement always checks. If something is true.
True. Right. Okay.
Yep. So you should knock out the equals true, but basically that's the format you might see. You would never see a .true or something of that sort. And I think it might have eaten the parentheses.
Yeah, I'm fixing it.
Okay. And so now, if you try it.
Yeah, zips right off there.
So because the other half of making sure it's smooth is that it's not currently frame rate independent. And so this is the time thing you were thinking about. And so that's where that transform forward. The problem is right now, every single frame, no matter how much time passed between frames, your full forward vector. You're going to move forward by 1 unit, whether
Right.
it happens 60 times a second or 20.
So I
What
could
you do
take
if-
this times 0.2 or something.
Sort of. Well, so in addition, the frame rate independence comes from multiplying times how much time passed between frames, which is something that
Right.
we have to ask Unity what that answer is. And so that's you're going to multiply times time dot something. And again, you might browse the dot menu to see if you can remember which one of those it would be.
Time dot delta time.
Yep. And that is how much time has passed between frames as seconds. And so if it's half a second between frames, this would be 0.5. If we have 4 frames a second, it'd be 0.25.
Yeah,
Typically,
that's
of course, it's much lower.
Yeah, that's frame dependent, and then there's real time, which is frame independent. So it can actually, that's where you can get choppiness, right? There's one that's frame dependent, and there's one frame independent.
Oh, so I mean, so you could avoid fixed update. Might be what you're thinking of.
Yeah.
And fixed update is called like 20 times a second, regardless. Whereas update is called depending on how rapidly your graphics card can keep things going.
Okay.
Yeah, and so if you try this now, your thing should be moving much slower, but smoother. W key?
Up there it goes.
Yeah.
It's taking us. I wasn't in the window. I think I was clicked outside. Yeah, that's
Right.
what happened. All right, so it's like a bus now. It's just kind of
There we
leaving the
go.
station.
Yeah. Speaking of which, actually, let's make that ball physical, just for
Yeah, so it'll
give it
drop
something
down.
to do. Yeah, yeah. You ever had to make a ball have physics on it?
We got the spear colliders already on there.
But there's specifically something else we need to add.
We got the no physics material, so we need to add a physics material.
No, we do not.
We do not? Okay.
We do not. So you need to add a specific kind of physics component. So if you look up in your components and look inside physics, and this one I don't even think we've ever actually needed to use this in your game, but yeah, rigid body is what tells it to like flop around and be physical. The very top one.
I already. Oh, it's got a collider, not a rigid body. Okay.
Yeah, yeah. So the collider defines like what is the space of this object.
Yeah. When is it being collided with? Right.
Yeah, the physical presence. Whereas rigid body is what like allows it to tumble around and do physical stuff.
Right. So now
So
it should just fall down and do
drive
this.
away from
Yeah.
us.
Yeah.
Well,
Sure.
I know. No, so the physics material you're looking at, that's what might allow it to be bouncy or high friction or other stuff. But we don't actually need those in this case, or we're not worried about those. So now, can you set up your cube to turn when you're holding down another key? And let's also go ahead and get rid of the your console log for W key press, because of course it's
So yeah, it's getting horrendous.
yeah. Although actually, speaking of it being horrendous, in your console, do you remember how to make those all take up a single line instead of a whole bunch of them? If you look at your console.
Oh well, that would. It's got to be a thing.
One of the
Is it a right click or is that right here?
you moused over it. It's that collapse option, left of clear on play. If you look at collapse, top left,
Collapse. Oh, okay, there we go.
and that'll just show you that it happened 272 times. As long as those lines are identical, it'll just increase that number
Right.
instead of making a new one.
That
but-
really is, yeah, that should be helpful. All right, but
All
we
the
don't
same,
need it
yeah.
anyways.
Yeah, yeah.
We know what's happening.
Yep. Okay, so now let's add another key check to decide if you are turning.
Okay. So do another one. So we want to probably do D.
Yeah, that's a fine choice.
Yeah, I mean
So
we're
now-
doing our WAS, so
Yeah, yeah.
and we want to go
And this will
right.
be so this is going to be quite a bit different. So that would be if you want to slide to the right. So which could work fine, but we want you to turn.
So we want our transform dot rotation.
Although we're actually going to have to do it a little bit different than the way position was, because rotation isn't something you can just add to in the same way you can position. Rotation is represented in Unity as quaternions, which means we have to use functions to intermediate with it. So let's get rid of everything to the right of rotate.
Okay. Oh, so still keep rotate though.
Yeah, we're going to keep rotate, but everything else is going to go away, including the plus sign. Because rotates is a function that wants some arguments.
Okay.
And there's a few different versions of rotate. If you open up your parentheses, you see some options when you press your up and down arrows. And let's see if any of those.
Okay, so vector 3 Euler angles.
Euler.
Euler. Okay.
Yeah, yeah. European name.
I'm sure it is. I'm glad that you're here to help me pronounce things. Vector 3 axis, float angle.
So there's a few forms of this we could use.
Euler angles relative to.
Basically, we could say, like, here's a pole, and here's how many angles I want you to take around it. One of the forms that I find handy is this version 5, where you can just give it how many degrees are on X, how many degrees are on Y, how many degrees are on Z. And so that one's probably one of the simpler forms to work with in this case.
Okay.
So if you want your object to spin left to right, which one of the axes do you want it to spin on?
Left to right. I would want to spin. Well, I'm keeping the Y-axis the same, and I'm moving the Z and the X, right?
Well,
I'm changing them.
So you're not changing those axes, though. You have to think of it as there's a pole. That pole is your Y-axis that you're spinning on. And so you want to rotate on Y. So basically, this means that there's not going to be any X or Z change. The rotation is going to be just a middle number.
Okay.
So in this 3-argument form, what would you tell it for your X?
Float 0.
So you don't see float here. Float's only needed if you're declaring your variable.
Okay, so.
But you're right that 0 is the
0.0 because it's a float.
Yep.
Comma.
And then, although it also likes to have an F after it. Whenever you have a
oh, that's right. You're right. Yep.
Yeah. That might have been what you were thinking of. And so now it wants the Y amount. Now this one's going to be the one that's non-zero. So this one could be.
So maybe like 20. Is that going to be a lot?
No,
I guess we'll find out.
Yep.
0.0 F and then that and then that. Is that actually going to work?
Well, let's find out. That's the first thing to check.
Yeah. So if we're D, it's probably going to go the opposite direction too. I probably have it.
Well, it's rotating.
Yeah.
Mission
really
accomplished.
Yeah. Yeah, take that, you ball.
There you go. Well, so the other thing, right, is that it's not doing frame rate independence in the same way your motion is. You should be using your time.delta time.
Right. So times time.delta time.
Not the whole expression. The whole expression is a function without a return value. It's going to have to be one of those arguments.
Oh, okay. So it'll be the middle one.
Yep.
Times. So what kind of numbers does delta time return?
So it's how many seconds have passed between one frame to the next. And so if your frame rate is like 20, this would be 0.05.
Okay.
If it was you have a frame rate of 8, it'd be.
But typical frame rates are 30, right?
Yeah, yeah. So I mean, so typically we're probably looking at 1 divided by 30, 0.03. And of course, if you had a great frame rate of 60, it'd be like 0.016. So pretty small on the order of things.
Right. So that's one of those things where like you wouldn't use that if you were playing with an online game, because everyone has different frame rates.
So sort of. I mean, so for online code, there are some different ways to mediate their motion. But you're right that we wouldn't want this to affect the positions of things for gameplay logic in the same way.
Right.
They'd all have to be kept on the same time step.
All right. So now, yeah, much better.
Yeah.
Much smoother. We can turn it. And I'm turning it the correct direction. I'm surprised that I actually got that right.
That's a 50-50 chance.
Yeah, it was a 50-50, but still. Well, I guess I can't collide with it either, though. I need to put a collider on the box. So let's do that.
So the box should already have a collider.
I mean, not a collider, but a physics component. Yeah. I'm using those two things interchangeably, and I need to stop doing that. Physics rigid body.
So that's a 2D one.
Oh, that's it.
It does not want.
Box collider.
Box collider is what it already has.
Oh. So let's remove that.
Good practice at removing a component, though.
Yeah, there we go. Practice.
There you go.
Component is physics, rigid body. It already has a collider, so it's just a rigid body. Right. Okay. There we go. Maybe that would be it. So now maybe I should be able to push it around.
You were actually able to a little bit of time push it some of the time before, but you're right that typically a non-rigid body interacting with a moving collider can be weird.
Well, it was probably the edges because I was spinning so fast. That's probably why I was able to push it.
The game engine does prefer there to be rigid bodies on anything that's moving.
Oh, look! It even like pushed me back a little bit.
Yeah. There you go. much more reasonable behavior. So let's on your player, because right now there's no way for you to tune your forward speed or your turn speed, how much you expose those values to the inspector. So you could tweak from the inspector how fast it drives and how fast it turns.
Right, so we need to go ahead and make some variables, some public variables. So just come up here into the mono behavior. I have to at least be in there. So we'll make public int, or actually this is going to be a float. We'll call this spin speed, even though the other one is what we want. And then the other
both.
Public. Well, this one can come second after, and this will be the forward speed. Forward speed. I need to make that a float. Float. Forward speed. And I guess we can default the values to what we already have, and then put those things where they are.
Also, what are they that you already have?
Ooh.
What is the default speed of forward speed right now?
Nothing.
Well, sort of.
There's no.
Zero.
It's not zero, but it's whatever the transform is saying. So.
So transform forward will default to normalized value of 1.
1. So it's.
Really, it's 1.0f is what your default forward speed is.
Okay, so I'll make that equals 1.0. And then spin speed is 20.
And don't forget your F's on those. Your compiler's going to be unhappy.
0F. F. So come in here and change this to spin speed. And then come in here and change.
You're going to have to. Just going to change them.
Add a new variable. So it shouldn't matter if I add it here or at the end, right?
It says it's being multiplied. The order won't matter.
Right. That's what I hoped was true. You know, that's typical math functions. That's how things work. But
you are right to be suspicious. There are things like if you're ever multiplying a quaternion times a vector, the order will matter. And that's because it's not really doing multiplication. It's doing some fancier math transformation stuff to it. Yeah.
Because math.
Yeah, because math. But yeah, basically what happens is you can develop a quaternion that will rotate a vector, and the order that gets called in has a big impact on what it does. And so now you should be able to tweak those speed and spin values when it's running.
Okay, so it's going this fast. We can make it even faster. And now it's even faster. I could change the spin speed. Of course, it's out of frame now.
Well, it's very tough to see the top of your cube because it matches the ground.
Yeah,
let's put a color on your cube.
Yeah. So
remember how to do that?
Yeah, that's it's gonna be mesh renderer.
So you're gonna have to create a new material first.
Right. So.
Because you're totally in a blank scene. Speaking of which, just go ahead and save your scene. I don't know if you've actually saved since we created the scene. Not that there's anything super important we don't want to lose, but you know.
Actually, should just save the project. Yeah, and then I guess we'll just call it practice. So now it's actually a scene. It wasn't even a scene before this. And then we need to add a folder. Let's go ahead and create a folder for all of our materials to go into.
Good call. I'm going to have to bring a little order to it.
Yeah. Do I want that in the assets folder? I guess I do. Yeah, that's fine.
Yeah, generally almost everything is going to live inside your assets.
And then if I right click and say new, create new material. Material should be right there. And then we'll just make this a nice, I do like red.
Sure.
So we'll make it a nice red there. We don't need to make it transparent. I guess we'll make it a little bit transparent.
Now, if you do that, you're also going to have to change your rendering mode to acknowledge the transparency. At the very top of the maps material, see where it says opaque? So by default, it ignores your transparency channel.
Right, so now it's a little bit transparent. Okay. Now if I come over to my player, and I go over to there's a thing for this, or do I have to add something?
There's a couple ways you can get at it.
Material?
One is you'll see it says mesh render in the middle.
Yes.
There's an arrow next to materials. You could click left on that arrow, left side.
There it was hiding.
That'll show it to you. Or at the very bottom, if you click on that, yeah, you can assign it that way. Now the other thing you could do in this case, because your scene has so few elements in it, you can actually just drag your new material onto your cube in the scene, and it will apply it that way.
Right.
Which would be handy.
So now we got this nice
fancier glass cube.
Yeah.
And of course this one, yeah, the shadow doesn't kind of play nice with it.
Well, if it was like a red shadow, it could cast shadow. I do like the way that it, like when it hits the ball, like it actually gets pushed back a little bit.
Yeah, since it's got a proper rigid body on it.
Yeah, I like that.
Okay. And so now let's get it so we've got.
Could probably turn the other direction, but that would be easy to do. I'm not going to worry about that.
Okay, well, so there is another way we can use our movement keys, and so let's take a look at using those. Instead of using get key, let's use get axis, which is a mechanism that allows us to use sort of a wider variety of input devices. It'll allow up arrow and down arrow, W and S. It'll actually allow your joystick or gamepad to do the same thing. Right, we just did this with the game. Yeah.
So we could get the cameras moving around properly.
And so in this case, if you'll basically, let's comment out your if get key W case. And remember how to do a multi-line comment?
Yeah, it'd be star and then / or is it / star? It's / and then star.
Yeah. Stars go on the inside.
And then on the other side it'll be star and / and not a question mark, a /.
Yep.
Yes.
Okay, so now if we're going to use the get axis, well, first of all, let's just do a debug log here, just printing out the axis value, so we'll make sure we're kind of visualizing what it's doing.
Okay, so debug log, and we want to get the value. Do we don't have a variable yet, or I guess
what we're going to print out is input.getAxis.
.getAxis. Okay.
And now the way to find what axis you can give it, if you go back to your Unity environment, and we'll go to edit.
I'm just trying to. Well, will we say any words? You think?
There's going to be some other stuff here, but to find the words, and so getAxis needs parentheses. It's a function.
Okay.
But the words, yeah, we're going to go back there. Check out your edit up in the top left menu, edit, project settings, and then input. And so if you'll click there, it says axes. Those are options we could stick in there. They're the ones that are axes. And so in particular, horizontal and vertical, if you unfold one of those, and you'll see it's got a name on it, it's got a vertical, it's defining it, saying, okay, this can be your key or mouse button. You'll see it has some positive buttons, some negative buttons, some alt positive buttons. So it's saying like up arrow or W key will work as vertical.
Right.
One direction and so on. Now you'll also see horizontal and vertical appear lower in the list as well, after mouse scroll wheel. If you unfold those, you'll see it's also an axis, but it's using joystick axis instead of a key or mouse.
Right, something axis. From like analog.
And so what this is nice about is that this actually, if you use the same names for multiple ones, any of them will still catch it. So you could plug in a gamepad and it should just work if we use an axis.
Right.
But these are the words we can use in this case. And we could reword these, but for now, let's just copy the word vertical out of here. And I like to copy it straight out of here, even though I know it's horizontal and vertical, just because these are strings. And so if they mismatch, Unity will not give you any kind of error per se.
Okay.
And that parenthesis, of course, needs to wrap your string.
So vertical. And you're saying that that's going to be
so those quote marks need to be removed and go around the word vertical.
Okay. So these ones.
All. There will be no quote marks there where you have them. They're going to go around the word vertical.
Oh, inside here.
Yep. Yeah. Because what we're saying to axis is like there's a name for a string that it's going to be looking for, and that's one of them. And so let's just print out that value and see what kicks out. It's going to need a semicolon at the end of the line, as always, or it will be unhappy.
Yep.
And so if you press play.
So I say, what is that, W?
And you'll see what it's doing with that number.
I see there's the negatives and the positives.
When how high does it get when you hold down W?
99.
Goes up to about 1-ish if you let go. Pulls down to 0.
Negative 99.
Yep, and if you let go either, then it should take it back down to about 0.
Yep.
So because at any given value, any given frame, this gives you a number. And if it thinks you've let go, then it's basically trying to give you 0, or pretty darn close to it. Because of that, we don't actually have to put this inside of an if statement. We can just constantly have this applying force to your ball. And it's going to basically, in the same way you can multiply your speed times it, if you multiply your axis value times it, then W is going to bring it up to +1 of that. S is going to bring it down to -1 of that.
Right.
And so you can actually just kind of copy your expression from your if statement, or you might write it again just for practice, but really it's your transform position line.
Okay, so if input dot, and then when this is going to be get axis.
Yep.
Axis.
Also, there's no if statement anymore. No if statement whatsoever. That's what I'm referring to.
Oh, we don't need it.
It's always giving you a number back from -1 to 1.
Okay. Input get axis.
But you're not. But it's going to look exactly like your transform position line from before. Transform position plus equals.
Oh, okay.
Forward. The difference being you also multiply your transform get axis times it.
Position plus equals transform dot forward times, where's the times, is right on the 8, and then get axis, input dot get axis. Dot get axis. So, and then plus times time dot delta time.
Get axis still needs to be told which axis to get.
Which is going to be vertical. Okay, so vertical, and then times time dot delta time. Delta time colon, and that should work. So basically forward and backwards.
Yeah. And you'll see it's got kind of some lagginess to its movement in the same way as the numbers we see output down there are follow a full gradient from 0 up to 1.
Right, so it's slowly is stepping up to get to its speed.
And that's what's got to do within the input values. We saw there were numbers like gravity, dead zone, and so on. That's where it's trying to simulate, like you're using your arrow keys as though they're an analog stick.
Right.
In some games that's appropriate, in some games it's not. Sometimes if you want something more responsive, you can actually change your get axis to get axis raw, and it will not smooth it out for you. So if you press W, it'll instantly be 1. If you press S, it'll instantly be -1. If you let go both, it'll instantly be 0.
Right, for fighting games or whatever, that's important.
Or, yeah. Or, you know, even if you just want kind of a more retro style ship or car movement, like an older Atari kind of game, then you might just want to snap into responsive action.
Yeah.
Alright, let's see.
There he goes. So we got 30 minutes. Do you think we could work on?
Shift over to some 6 stuff.
Yeah, I think we'll save this and we'll see what we can do over there.